Hi, I received a question about how to get started with doing the bootstrap technique in StatKey. So I am going to do Chapter 3, Section 3, Exercise 71 as an example, and hopefully it will help you with the later questions. So information about the proportion of a sample that agrees with a certain statement is given below. We're going to use StatKey or other technology, and we're not using other technology, we're using StatKey to estimate the standard error from a bootstrap distribution generated from the sample. Then we're going to use the standard error to give a 95% confidence interval for the proportion of the population to agree with the statement. So here we have a random sample of 100 people and 35 agree. So if we are going to use StatKey to do the bootstrap distribution, we are going to need to know that that's our sample size is 100 and 35 is the number that agree. Okay, so I'm going to click to access StatKey. And make the window bigger so we can see what we're doing. Okay, so I need to go into bootstrap confidence intervals, and I have a single proportion. Now remember, I have 35 agree out of 100 people. I need to enter this data, so I click Edit Data, because right now I have 52 out of 100 is the original sample. My sample is 35 out of 100, so I do Edit Data. So the count is the number who agree, 35, and the sample size is 100, and I click OK. Now this reflects my sample. It's a sample size of 35 with a proportion of 0.35. And now what I'm going to do is I'm going to generate a whole bunch of bootstrap samples, which means they're sampled with replacement from this original proportion. So we need thousands of samples to make sure that we are going to stay within the tolerance of Wiley+. So I'm going to generate 5,000 samples. So there's, click 1,000, 2,000, 3,000, 4,000. Click again, there's 5,000. Okay, so now I can see the standard deviation of the bootstrap distribution is 0.047, and that is the standard error. The way we estimate the standard error is by taking the standard deviation off the bootstrap distribution. Okay, so now we have our estimated standard error. Okay, so our estimated standard error, that was what we just took off of here. Let me just grab that again. 0.047. Okay. 0.047. Okay, there we go. Now to find our confidence interval, we are going to take our original sample estimate. So that's our p hat, which is 35 out of 100. And we're going to use our margin of error. Okay, so now what I want to do is I want to make my confidence interval. So to do that, I am going to use my point estimate plus or minus my margin of error. My point estimate is p hat from our original sample. And my margin of error is 2 times the standard error that I just found with the bootstrap distribution. And I use SE for the standard error. Now I know my p hat was 35 divided by 100, so that's 0.35. Plus for the upper limit minus for the lower limit, 2 times the standard error. Now my standard error was 0.047, I believe. Let me just, yep, that's right. So 0.35, whoop. Okay, so if we take 0.35 minus 2 times 0.047, that gives us a lower limit of 0.256. If we take 0.35 plus 2 times 0.047, let me grab my calculator, 0.35 plus 2 times 0.047, that should give us 0.444. So our confidence interval is going to go from 0.256 up to 0.444. So now I just need to enter this into Wiley Plus. So come back over here. Okay, so my confidence interval, I need to make sure I put in the lower limit first, is 0.256, and that's to 3 decimal places, so that's what it's looking for. And my upper limit is 0.444. And now I submit my answer, and it's correct. Pardon my dogs. I hope this video helps you. I don't want to have to record it again because I've done it several times, but I hope this helps, and I will go through another example in class tomorrow. Have a good night.